In the Dr. Pepper situation, remember, we had a cup that was half full, and we poured water in that cup. We caught the overflow. Okay, just concentrating on the cup. If we were pouring water at a constant rate, whatever that rate is, the initial concentration of Dr. Pepper we took to be half. Cup half full of Dr. Pepper, the other half full of water. So Q naught would be half the volume. In other words, the volume, the quantity of Dr. Pepper is half the volume of the container, okay, the cup. So that Q of T, and of course this is a function of T, is 1/2 V times e to the negative R over V times T. We didn't measure the rate at which water was poured into the cup. Okay, what we did was we just poured all the water in the bottle into the cup, more or less gradually, so the water would mix. And then we took a look at what we had. So what did we have? Well, if the water thoroughly mixed, it really doesn't matter whether we poured it in at a constant rate or not. Now, if we want to get our exact function Q of T, it does, but the end result, what was the concentration of water in the cup at the end? We can answer that without knowing the rate or without even assuming a constant rate. We have this function. I'll simply say, well, okay, if V sub n is the volume of water that we poured into this cup, then if we had poured it at a constant rate, then at some point R times T would equal the volume that we poured in. And in that case, the Q would be 1/2 V over 2, times e to the negative R over V times R times T. And R times T is Vn, so that negative R over V times T is just Vn over V. So that our quantity is just V over 2 times e to the negative Vn divided by V. Now, we estimated that the bottle that we poured in had about 2 of the styrofoam cups worth of water, so that Vn over V was just 2. So that the quantity of Dr. Pepper in the cup at the end was just the initial quantity, V over 2, times e to the negative Vn over V, which is e to the negative 2. And e to the negative 2 is about 0.13, I think. So if we do V over 2 times 0.13, we get approximately 0.06 something V, maybe 0.65, but I could be off a little bit on that. So we have about 6% of the Dr. Pepper remaining. And this tells us then that if we pour the water into a cup half full of Dr. Pepper, half water, and pour twice as much water as we've got solution in the cup into the thing, the water thoroughly mixes and overflows, we're going to end up with about 6% of, about a 6% solution of Dr. Pepper in the water. We don't know exactly what the function is, but that's kind of a neat thing to be able to understand in terms of this function.